Welcome back to my YouTube channel all about VLSI. In this particular course of computer organization, we are going to discuss about booth multiplier. Now, this particular booth multiplier is used to perform multiplication between two signed numbers, right? First of all, let's see the flowchart of how this particular multiplication process is happening. Next, let us try to understand this particular process with one example. Now, here we are going to basically consider multiplicand and multiplier. Okay, so multiplicand is basically stored in one register which is known as B, and multiplier is going to stored in one register which is Q. So let's have a few registers. So multiplicand is basically stored in a register which is B, and multiplier will be stored in one more register which is Q. Okay, so and also we are going to have one more register which is accumulator. Okay, so this is one more register which is accumulator which we are going to have. Now, and also we are going to have a track of count. So it depends upon the multiplicand, whatever the multiplicand we are going to have, that many number of bits will be stored in this n. Okay. Now, so we are going to have one more particular small register, one bit register, which is qn plus one, and in some terminologies, it is also represented as qn minus one. Okay. So let's try to understand this with one example so that the things will be more clear. So let's say if I'm going to have this registers accumulator. So this is my step number one. And in my step number one, I'm going to have one accumulator present. And my Q register, which is going to store the multiplier value. And one more register is Qn minus 1, which is only going to store one bit value. Whatever the right shifted content which is present inside this Qn, that will be stored inside this Qn minus 1. Now, this accumulator, let's say if I'm going to multiply two numbers, minus 5 into 4. These are my two numbers which I'm going to take. Now, basically plus 5 is represented as 0, 1, 0, 1. And minus 5 is represented in its 2's complement format, which is if I'm going to perform 2's complement on it, it is basically 1, 1, 0, 1. This is nothing but my minus 5 represented in 2's complement format. And plus 4 is represented as 0, 1, double 0. This is nothing but my plus 4. So I need basically 4 number of bits for representing this minus 5 and plus 4. Now, that's the reason my accumulator is also 4 bits. So accumulator is basically initialized with 1, 2, 3 and 4 number of bits. And my multiplier is basically loaded with, this is nothing but my multiplier. Okay, and this is nothing but my multiplicand. So multiplier will be loaded over here, which is nothing but 0, 1, 0, 0. And this qn minus 1 initially it will be equal to 0. Okay, now I have loaded everything, and here n value will be equal to 4. N is equal to 4 initially in the step number 1. Now, depending upon my qn and qn minus 1, that means this particular value and this value we are going to consider. Qn's LSB bit and qn minus 1 we are going to consider. If these are equal to 0, 0, what is that we are going to do? We are going to perform arithmetic right shift, and we are going to decrement our count value. Okay. Now, we need to perform arithmetic right shift on the accumulator, qn and qn minus 1. So whatever the content which was right shifted on this qn, that will be stored inside this qn minus 1. So what happens if we are going to perform arithmetic right shift? So in the case of my arithmetic right shift, the sign bit is not changed. It is being basically restored. So here the sign bit will be the same. That is nothing but 0. And this will be shifted towards right. 0, 0, and this is 0. Okay, and this content will be shifted into this qn register, and this will be 0, and this will be 1, and this will be 0, and this will be shifted towards right side, that is 0. Right, now this has been completed, and n value will be decremented to 3. N is equal to 3. Okay, so over here if n is equal to 0, we are going to basically complete the process. N is not 0, so basically what we are going to do, we are going to repeat this process again. So we are going to enter into step number 2. So let's enter into step number 2. Now in my step number 2, my accumulator value is 0, 0, 0, 0, and my qn value is 0, 0, 1, 0, and my qn minus 1 value is 0. Okay. So this is the content which I'm going to have, and my n value is now equal to 3. Now again, my Qn LSB is 0 and my Qn minus 1 is equal to 0. If it is equal to 0, 0 or 1, 1, I should basically perform arithmetic right shift. So which is nothing but 0, 0, 0, 0, 0, 0, 0, 1. And this will be 0. And n value will be equal to 2. Okay. Now, since n value is equal to not equal to 0, we can go to step number 3 and again we can perform the process again. So in the step number 3, my accumulator value is 0, 0, 0, 0 and my Qn value is 0, 0, 0, 1, LSB is 1 and Qn minus 1 is 0. So Qn LSB is 1 and Qn minus 1 is 0, which is 1, 0. If we are going to have 1, 0, then what we should do, accumulator we should subtract with BR register. B is nothing but your multiplicand. Now what is the multiplicand over here? Multiplicand is minus 5. Now what we should do, AC is equal to AC minus multiplicand is nothing but B. Now, that is nothing but AC is equal to AC plus B only, right? Because multiplicand was negative. So, minus into minus is plus. So, we should basically perform AC is equal to AC plus B. Now, which value should I consider? Whether to consider minus 5 or whether to consider plus 5. You should consider plus 5, not minus 5. Okay. So, because we have plus B. So, plus B is nothing but plus 5, which is 0, 1, 0, 1. So, AC is equal to AC plus B. AC is nothing but all zeros plus B is nothing but 0, 1, 0, 1, which is nothing but 0, 1, 0, 1. And the Qn content is 0, 0, 0, 1 and Qn minus 1 is 0. Now, after performing this particular subtraction, we have performed subtraction, not addition. Okay, AC is equal to AC minus BR. Since BR was negative, minus into minus is plus. So we have performed AC is equal to AC plus BR. That's it. Now, after performing this, again we should perform right shifting operation. So, what is right shifting operation if we are going to perform? That is especially arithmetic right shift I should perform. So, what is arithmetic right shift? It is nothing but 0, 0, 1, 0, 1, 0, 0, 0, 1. This is the last step in my step number 3 and my n value now will be equal to 1. So n is equal to 1. So again we can perform the process again. So in the step number 4, what is that I'm going to have? The accumulator value is basically 0, 0, 1, 0 and my Qn value is basically 1 triple 0, 1 triple 0 and my Qn minus 1 value is basically 1. This is a value which I've got. Now, what we should check? We should check Qn's LSB and Qn minus 1, which is 0, 1. If we are going to have 0, 1, we should basically perform AC is equal to AC plus BR. Now, what is this particular BR given already? Minus 5. Okay. Now, we should basically perform AC is equal to AC plus BR, which is nothing but we are basically performing AC is equal to AC plus minus BR because BR was negative, right? So which is nothing but AC is equal to AC minus BR. This is the operation we should perform, right? So I should perform subtraction between this accumulator and this particular thing. So instead of performing AC is equal to AC minus BR, what I can do basically AC is equal to AC plus 2's complement of BR. This is what I can do. Instead of subtraction, I can basically perform AC is equal to AC plus 2's complement of BR, which is nothing but 0, 0, 1, 0, 0, 0, 1, 0 plus 2's complement of BR is nothing but 1, 0, double 1, 1, 0, double 1, which gives me 1, 1, 1, 0, 1, 1, 1, double 1, 0, 1, which will be stored inside my accumulator and Qn content is 1 triple 0 and my Qn minus 1 is 1. And after performing this, again we should perform arithmetic right shift, which will basically restore your sign bit. In the case of your arithmetic right shift, you should not change your sign. It will be restored. It will be 1 and this will be 1, 1 and 0. And this will be shifted over here 1, 1, 0, 0 and this will be 0, right? So this is a value after completing my step number 4 and n value is basically 0. So over here n value is basically 0. So this is the content after step number 4 which is being available, that is nothing but 1110 1110 and I should not consider this Qn minus 1. So this is my final answer which I'm going to have, which is basically present inside your 2's complement format. And if I'm going to perform 2's complement again, I'm going to get my answer, which is a negative number. Since my MSB is equal to 1, it's a negative number. And the result is nothing but 0, 0, 1, 0, 1, 0, 0, 0. So this is my actual result which I'm going to have, right? So what is this value, which is nothing but minus 20. Okay. So that is what we need to have. That is what we have got. Okay. So this is how we are going to basically perform Booth multiplication. So if you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.